Hey, what's going on, guys? In this video we are going to see how to find out the Laplace transform of differential equation. Here we have y double prime minus y is equal to e power 2t, and we have the initial conditions provided. Y of 0 is equal to 0 and y prime of 0 is equal to 1. Okay, now let's see how to find out the Laplace transform. First of all, you have to know that like when we have y, it's similar to f of t. Like if you want to know how to find out the Laplace transform, you can watch my other videos. I have explained how to do that. Let's look at the Laplace transform of each of these terms and then we are going to convert. Okay, so first, Laplace transform of y. Laplace transform of y is equivalent to, this is equivalent to y of s, and then Laplace transform of y prime is equivalent to s y of s minus y of 0. Then Laplace transform of y double prime is equivalent to s square y of s minus s y of 0 minus y prime of 0. Okay, you may have seen this one in terms of f of s, like capital F of s, then small f of 0, f prime of 0. It's the same thing. Instead of f we have y right here, because the function have y double prime minus y is equal to e power 2t. And also we have to know the Laplace transform of e power 2t. I hope you guys already know the table. There is a table to do the transformation, Laplace transformation. Like in this situation, like if you have reached this far, it means you already know the table. So I write it, I write the answer directly right here. This is going to be 1 over s minus 2, because a is 2, so this is s minus a. That's why we have s minus 2 right here. Okay, now let's go ahead and convert the whole equation into Laplace transform like this. So if we do that, first we have y double prime. Y double prime is this whole thing, so s square y of s minus s y of 0, then that is okay, y of 0 minus y prime of 0, that is y double prime, then minus Laplace transform of y, that is just y of s. Okay, y of s, and that is equivalent to e power 2t. E power 2t is 1 over s minus 2. Okay, now let's try to simplify this one. Here we can just get rid of this bracket, because this is just unnecessary. Okay, let's see. If we take this bracket, yeah, it's not going to affect anything since there's no multiplication, so I can put it like that. And here we can take a y of s common, y of s, and before we do that, let's plug the values. We have initial values provided. We have the values for y of 0, that is 0, y prime of 0, that is 1. So before I take the bracket, let's put this one, s square y of s, and here we have s times y of 0 is 0, so I put 0 right here, and minus y prime of 0 is 1, so I put 1 right here, and here we have y of s, that remains the same. In the other side we have 1 over s minus 2. Now s times 0, that's going to be just 0, so s square y of s minus 1, because this is 0, this one remains, minus 1 minus y of s, that is equivalent to 1 over s minus 2. Here we can take y of s common. If you take y of s common, this is going to be s square minus 1, and we can move this 1 to the other side, so this is going to become, so let's put the minus 1 right now, and that's equal to 1 over s minus 2. Let's continue right here. We have to just separate y of s term alone. So first I move this negative one to this side, so this is going to be y of s times s square minus 1 is equal to 1 over s minus 2 plus 1. Okay, then s minus 2, to add them together, what we can do is we can take the common denominator. So y of s square minus 1 is equal to 1 over s minus 2 plus s minus 2 over s minus 2. Okay, now we can add them together. If we add the numerator, that's going to be just s minus 1 over s minus 2, and we can bring this s square minus 1 to the denominator, so this is going to be y of s is equal to s minus 1 over s minus 2 times s square minus 1. S square minus 1 can be written as s plus 1 s minus 1, so s minus 1 over s minus 2, then s plus 1 s minus 1. Here we can cancel these two terms, s minus 1 s minus 1, so this will end up with 1 over s minus 2 s plus 1. Okay, now we have this one. This is y of s, but our purpose is to find out the y of t. So first, to solve this one, first we have to do the partial fraction decomposition, because we have to find out the Laplace inverse. We cannot find that one in this way. So what we have to do is we have to separate, we have to find do the partial fraction decomposition to find out the values. Let's go ahead and do that. So partial fraction. In partial fraction, 1 over s minus 2 s plus 1 can be written as a over s minus 2 plus b over s plus 1, and then what we do is we multiply both sides by this denominator, so s minus 2 times s plus 1. So here denominator cancels. We have to do the other side as well, s minus 2 s plus 1. So 1 is equal to, for the first one, s minus 2 cancels, so this is going to be a times s plus 1, and for the second one, s plus 1 cancels, s minus 2 remains, so b times s minus 2. Now we have to smartly pick up the values for s such that will make this one 0. So if 1 is 0, we can solve for the other one. So let's pick minus 1 for the first s. So if I pick s is equal to minus 1 for this one, this is going to be 1 is equal to a times 0, because minus 1 plus 1, that's 0, and here we will have b times minus 3, and if this is 0, so b is going to be negative 1 over 3. Now we have to solve for a. To solve for a, we have to smartly pick up a value for s such that this will make this one 0. So if I pick up s is equal to 2, this will become 0, right? B times 2 minus 2, that's going to be 0. So this is going to be 1 is equal to a times, since s is equal to 2, so this is going to be 3 right here. 2 plus 1, 3. Therefore a is equal to 1 over 3. A is equal to 1 over 3. Now b is equal to negative 1 over 3. A is equal to 1 over 3. So we will get, let's write with a different, okay, let's get rid of these first things. Okay, we need some space, so let me continue right here. Okay, so we found out a and b values. If we substitute in this equation, this is going to be what? We are going to have 1 over 3 over s minus 2 plus negative 1 over 3 over s plus 1. Okay, that's whole thing is equal to 1. Now what we can do is we can take this 1 over 3 common, so this is going to be 1 over s minus 2 minus 1 over s plus 1 is equal to 1. Okay, this whole thing is okay, we put this whole thing. Okay, now we have everything. This whole thing is equal to y of s. We can put y of s. Now our purpose is to find out y of t. So to convert this one into t, we have to take the Laplace inverse of this whole thing. Laplace inverse of this whole thing. Laplace inverse of y of s is equal to y of t. So Laplace y, therefore we can say y of t is equal to Laplace inverse of this 1 over 3 1 over s minus 2 minus 1 over s plus 1. Okay, this 1 over 3 is just a constant, so we can move this one to the front. Let me write with a different color here. Let's use green. Okay, so 1 over 3 is a constant, so we can move that one to the front. Laplace inverse of 1 over s minus 2 minus 1 over s plus 1. If you look at the pattern here, initially we have e power 2t. So here you can see s minus 2. Here a is like 1 over s minus a. If it's s minus a, then is e power at. So based on is, if this is 2, then e power 2t. Here you can see we have the same thing, 2, right? So 1 over 3, the first term is going to be e power 2t. And the second term you can see minus, what value we have? Minus 1. So this is going to be minus e power negative t. Okay, and that's it. That's the conversion. That is the y of t. This is the answer for this differential equation. This is the general solution for this differential equation, and that's how we solve a differential equation using Laplace transform. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn differential equations, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.